Hello everyone. Welcome to our webinar about silicone surfactants for low emissions polyurethane foam. My name is Nicoleta Raikova and I'm the product manager of the Performance Materials division. That is the home for our range of silicone surfactants. I'm going to be the host of the webinar and assist Dr. Josep Nadal, who is our speaker today. Dr. Josep Nadal is the technical manager for the polyurethane additives. Joseph joined Concentrol in 1998, and since 2002, he has been in charge for the silicone-based polyurethane additives, among other key solutions. He has focused on optimizing and developing new solutions in this area since then. Moreover, he also works in customer support and technical advice in close collaboration with our area managers to find the solutions that best fit with the requirements and needs of every customer. He has presented technical seminars at events such as the UTEC Asia, PO China in 2010, the UTEC North America in 2016, and PCE Europe 2017, among other events. He is continuously publishing articles in industry magazines such as PO Magazine International. The PO Magazine International is our media partner for this event. I invite you to visit and follow them if you want to have more knowledge about the polyurethane industry. And now, before starting with the presentation, I will explain the format. While Josep is speaking, you can write down the questions that you have. As you can see in your screen, you can find the enabled space on the right corner. And after finishing the presentation, I will put these questions to Josep. And now I hand over to him.
Good morning and welcome to our webinar, Silicone Surfactants for Low Content of Aldehyde and Aromatic Emissions PO foam. In our webinar, we will have a look into a topic of main importance nowadays in the polyurethane industry. Emissions in plastics are one of the main concerns of customers, and its reduction is pursued in order to obtain products with low odor, lower toxicity, and more environmentally friendly. Although emissions are important in every type of polyurethane, in flexible applications, and especially in the automotive sector, it's nowadays a must to produce foams with very low VOC and odors. When we talk about emissions, it's sometimes helpful to understand what is behind the general name. Emissions are chemicals that are released from a PU foam under certain conditions. For that reason, when we talk about emissions, in many cases, we will consider the volatility of those chemicals and also its reactivity with other components of the foam. Also, we need to consider the regulations and toxicological restrictions of some of those chemicals. An example are the cyclic siloxanes. In other cases, some chemicals can be generated when a foam or its raw materials are aged. So aging of the components of the polyurethane formulation and also the polyurethane foam, when it has been already produced, is a parameter to consider in the evaluation of the emissions. So in this slide, we will summarize some of the most typical methods for the analysis of emissions used nowadays in the polyurethane industry. We have the thermodesorption methods that are used for the analysis of VOC and fogging, so low and high volatile compounds. Have heat space, which is another chromatographic technique that's a little bit less common, but it's useful for the analysis of some specific very low boiling point substances. We have sampling bags that are widely used nowadays, mainly for screening purposes, thanks to its relatively low cost. When we talk about chamber test methods, we need to consider that there are methods that use as microchambers, and also there are methods that use as a small chamber test, like the ones that are using a chamber test of 1 cubic meter. They are methods that had a high degree of precision, but usually the analysis of it's costly, so they are not used regularly for regular screening on production, for example. And finally, when we talk about the odor, we need to understand that nowadays still there is no analytical technique able to analyze the odors. So in most cases, we rely on the analysis done by trained people who is able to do this kind of test. In the next slides, we had summarized some of the examples of thermal desorption methods, like the well-known in Europe PDA 278, which is very useful in the analysis and characterization of most of the chemicals that are volatile. Considering the VOC, those chemicals that are desorbed at 90 degrees, and the fogging, those chemicals that are desorbed at 120 degrees. It's a very useful technique when we analyze a complex mixture of chemicals, thanks to the mass spectroscopy that allows the characterization of many substances in a single analysis. But it's not the right method for the analysis of highly volatile substances, like the aldehydes and some aromatics. Headspace methods can analyze some of these highly volatile substances, but the most widely used techniques for the analysis of aldehydes, aromatics, and also some VOC in general are the microchamber test and sampling bags that are able to analyze using gas chromatography the VOC and using liquid chromatography with usually DNPH cartridges, the carbonyl compounds like the acetaldehyde, formaldehyde, and propionaldehyde. A very well-known method using sampling bags is TSM0508G and also ISO 12219. They both rely on sampling bags, and they are able to analyze at relatively low cost the analysis of VOC and also carbonyl compounds. There are also other methods that they rely on using small chambers of 1 cubic meter, like BDA 276 and some ISO methods, and they are very useful for the analysis of VOC and aldehydes, and in most cases they are complementary to other methods like the BDA 278. Finally, nowadays, odor is mainly directly analyzed by trained people. It has not been yet developed a method based on analytical equipment to analyze the odor, although it's a main interest on the industry nowadays. When we analyze the odor of a foam, we consider that usually the analysis is done in dry and wet conditions. There are differences between the methods, like how many testers are doing the experiment, and also in the scale used. Like, for example, we see in this slide, we have scales that range from 1 to 10 or scales that range from 1 to 6. So we have seen some of the methods that are used nowadays for the analysis of emissions, but is it possible to establish which is the source of those emissions? We cannot exclude the importance of the quality of the air in the production zone, but it's generally accepted that we can focus the investigations in the following options. One is the raw materials, its origin, its chemical synthetic route, and also the possible presence of non-intentionally added substances. Also, the byproducts of the chemical reactions that take part in the preparation of the polyurethane foam, and also in the preparation of the raw materials used. And finally, we need to consider the appearance of substances that are generated after time due to oxidation processes or other degradation routes. So if now focusing the interest in flexible foam and more specifically in HR molded foams, we will have a look in a particular case involving silicone surfactants. When we talk about the contribution of the silicone surfactant to the emissions, although the silicone surfactant is used in a minor quantities, we need to consider its contribution in terms of VOC, in terms of fogging, also the presence of cyclic siloxanes, the possible presence of aromatic emissions, of carbonyl emissions, and also its possible contribution to the odor. For that reason, the evaluation of the emissions of a certain stabilizer is a complex topic, and in most cases, it's needed to use different methods to have a complete view regarding its contribution. So a clear example of emissions that are totally related to the silicon surfactants are the low molecular weight oligomers, specifically the cyclic siloxanes and also some linear MDM molecules. They are molecules that are formed in the reaction of the piloxyloxane polymer to form the silicon surfactant. From the synthetic point of view, its presence cannot be avoided. And for that reason, we will always have a percentage of those components in the final product. Thermodesorption methods can be used for the analysis of these low molecular weight siloxane components. Also, they can be directly analyzed in the silicon surfactant alone. So before the evaluation of a new silicon stabilizer in a pure formulation, the theoretical maximum values of them can be established by its analysis using gas chromatography with mass spectroscopy. Also, the expected contribution to the total VOC and fogging of a silicon stabilizer in a foam can also be measured using internal analysis patterns like C14 and C21 alkanes. It will allow us the measurement of all the volatiles that are classified as VOC and as fogging. An example of these chromatograms is shown in the slide, when we can see that the values obtained for experimental product 11B, they have more peaks than, for example, the chromatogram of EP03A. So we can easily see which of the surfactants will have a higher contribution in the emissions. As we said, besides the analysis by gas chromatography of the silicon surfactant, the analysis of the siloxane oligomers, it can be easily done using thermodesorption methods like BDA278. So we have summarized in this last slide some the chemical structures of these molecules, their boiling points, and some regulatory information based on the data from the European Chemical Agency. The declaration of these substances is mandatory if the quantity is higher of 0.1% of each of them in the safety data sheet. So it will be noticed always in the safety data sheet if the presence is higher than 0.1%. Concentrol has a wide range of silicon surfactants for HR formulations, which fulfill the requirement of having less than 0.1% of each of the cyclics. Another important source of emissions to be considered are the aromatic volatile substances. In the table, we have listed some of the main substances which is believed to be found in a polyurethane foam. We can see that they have boiling points which are between 80 degrees up to 150 degrees. So they can be easily released from a foam in summer, for example, in a car. Another important source, the source of the aromatics, is considered to be the usage of solvents in the synthesis of the chemicals. Although there are industrial processes that are able to remove the solvents, some remains can always persist. Also, some differences can happen from batch to batch. We do not expect to have any aromatics in the siloxane nor in the polyether because of its synthetic roots. So the synthesis of the silicon polyether surfactants without aromatic solvents is the guarantee to avoid volatile aromatic components in the surfactant. In order to fulfill the stringent requirements on this topic, Concentrol does not use any aromatic solvent in its production line. Another source of emissions are the low boiling point carbonyl type substances. The most well-known and considered by the industry nowadays are formaldehyde, acetaldehyde, acrolein, and propionaldehyde, and their chemical structures are shown in the table. Look at their boiling point temperatures. They all have boiling point temperatures below 50 degrees. Acetaldehyde and formaldehyde are gases at room temperature, so its emission from a foam is expected to be very easy. Their high volatility makes its analysis challenging. Their analysis, as we have seen before, is usually done using liquid chromatography with DPNH cartridges. Regarding volatile or carbonyl compounds, their origin is thought to be related to the degradation of some chemicals. Polyethers are the main source of carbonyl compounds because of its degradation via the oxidation of the carbon-oxygen-carbon bond. Polysiloxanes, although they have emissions of low molecular weight siloxanes, as we have seen, they are not considered a source of carbonyl compounds based on its chemical structure. They only consist in silicon-oxygen-silicon bond and silicon-carbon bonds, and none of them are able to be degraded by a path that generates carbonyl compounds. So considering both points, and in order to prepare silicon surfactants with lower contribution to the aldehyde emissions, the reduction on the polyether content of the surfactant has been found to be the best option. We have seen in the previous slide some general information regarding the emissions, the methods for the analysis of each type, and also some information about how Concentrol deals with aldehyde and aromatic emissions. We will now present analytical data regarding the emission measurements of some specific surfactants and also the analysis of foams prepared with them. So we will first see some analysis of the emissions, but doing the analysis directly on the surfactant. Then we will see the results of the analysis, but when we are doing the analysis on the foam directly. And finally, we will present some results regarding the foam odor from a final foam. So we will now present the analytical data concerning the emissions, but directly measure it on the surfactant. In this first table, we have an interesting comparison between the emissions that are found or can be found using the standard PF range of surfactants and the new range of references under the trade name PFJ. In general, we see in the table that the emissions of the three aldehydes are lower in the case of the PFJ references, but where the difference becomes more clear is in the propionaldehyde values. The reduction is really important, showing that the objective of reducing this kind of emissions can be achieved when new references under the PFJ range of additives are used. So in blue and green, the values of the emissions in a graphical representation, we should set that STBPU 1234 is a recommended surfactant for MDI. STBPU 1254 is a recommended surfactant for MDI TDI, and STBPU 1259, it's a good surfactant for TDI. In the next table, we summarized the results of the aromatic and aldehyde content of two of the new PFJ surfactants, STBPU 1254 and STBPU 1259 PFJ, and a comparison made with 6 different surfactants that were used for a comparative purposes. We can see that in most cases, the values are very low for all the stabilizers, but some values, especially formaldehyde and above all propionaldehyde, have a tendency to be higher than the values obtained with the new PFJ references. In the graph, the aldehyde values, in gray, we see the results of the 6 references that had been taken for comparative purposes, and in blue and green, the values obtained with surfactants from the PFJ range. We should remember that in this case, the analysis is done in the surfactant and not on the foam. Regarding the emissions of the aromatics, in the graph, we see that in most cases the values are pretty low, but also again, with the PFJ references, the values are lower than most of the silicon surfactants used for a comparative purpose. These very low values on the PFJ references, this is not strange considering that in the synthesis of this kind of silicon surfactants at Concentrol, we are not using aromatics in any case. And we will now see some results, but in this case of emissions, but measured directly on a foam. In this case, we had, as we said, we had not measured the emissions on the pure surfactant. We had analyzed the emissions on the foam. In this table, we have a comparison between the results of 3 PFJ silicone surfactants, 1234, 1235, and 1259. We had included in the comparison a silicone surfactant, a benchmark silicone surfactant, reference J. And we can see from the table that most of the chemicals, they do not change when we change the silicone surfactant. So it means that those emissions are not directly related to the silicone surfactants used. But we see that in the case of the acetaldehyde, we see a small increase when we use 1259 PFJ, but we see that in all the cases, the values obtained with the PFJ references are up to 10 times lower than the obtained ones using reference G. So it means that the PFJ references are really able to reduce the emissions on a foam, especially in the acetaldehyde content. And this is the graphical representation of the previous results, where we have found that the PFJ references always offer at least the same result when compared with the obtained ones using reference G. And in the case of acetaldehyde, the results are, as we said, up to 10 times lower than obtained ones for the comparative surfactant. The second experiment was the analysis of foams, but prepared with the different dosages of silicone surfactant. In this case, we had chosen the silicone surfactant 1259 PFJ, and we had make the evaluation using 0.9 parts per 100 polyol and 1.2 parts per 100 polyol. So it means an increase of 33% more silicone stabilizer. Also, we had included in the evaluation 2 other silicone surfactants for comparative purposes, so reference H and reference I. The comparison does only show that the propanaldehyde increases in a similar quantity than the stabilizer. Aromatics are not present in the PFJ range of stabilizers, so its analysis in the foam emissions should be related to other raw materials. We see that formaldehyde and acetaldehyde, they did not increase in a direct relation with the increase on the dosage, while in the case of the propionaldehyde, a direct relationship seems feasible, because we had increased 33% dosage of silicone surfactant, and the propionaldehyde has increased in a 30%. When the total values of STBPU 1259 PFJ at 1.2 parts per 100 polyol are compared with the obtained ones using reference H and reference I, which are references considered of very low emissions, with the results we see are very similar. From this experiment, we can conclude that some emissions can be directly related to the surfactant dosage, but other emissions, they are related to the foam itself on other components of the foam. Because when we increase 33% the dosage of the silicone, these emissions, they do not change, except for the propionaldehyde. Another important topic is the odor of a foam. It's a general complaint of consumers when they are in close contact with plastics, especially when they are recently produced. It's a very delicate sense, and it's regarded as extremely difficult to be quantitatively analyzed using equipment analysis. And also, we know that most chemicals, they have an odor, and also that, generally speaking, it's known that components that had lower molecular weight than 400 grams per mole are possible odor sources. So in the list, we had included some of the substances that can be analyzed using gas chromatography, and that had been usually considered as possible odor sources in polyurethane foams. So we have selected 3 stabilizers, and we had included in the analysis of comparative surfactants, reference G. We have highlighted in yellow the values that change when the surfactant is changed. So we can establish a relation between these 2 changes. only we see that only acetaldehyde, propionaldehyde, and butyraldehyde, they have this behavior. We see that many other chemicals, although we change the silicon surfactant, the values are more or less the same. So it means that these substances, they are not part of the silicon surfactants. We see that in this case, in the graphic representation, we see that surfactants of the new PFJ range of additives, STBP1234 and STBP1235, they do not increase the odor at all, while STBP1259 PFJ does it, but in a minor extent than reference G. This experiment offers experimental data supporting the fact that the new PFJ range of stabilizers, they do not contribute, or they have a very small contribution to the final odor of a foam. As a summary of the webinar, we would like to make a short review. We have seen how the emissions are measured, which methods are currently being used by the industry, the differences of the methods considering which substance has to be analyzed. We have also seen that some emissions are directly related to the silicon surfactant, like the cyclic siloxanes. And also we have discussed that Concentrol has a range of silicon surfactants for HR foams that fulfill the requirement of having less than 0.1% of each cyclic. Related to the aromatics, and due to the absence of aromatic solvents in our production line, we ensure that the presence of these substances is not expected in any of the stabilizers produced by us. Related to the carbonyl substances like the aldehydes, the new PFJ range of stabilizers we have seen have very low quantities, making them a good choice when this requirement has to be fulfilled. And related to the odor, the new stabilizers, they do not contribute emitting substances that are generally recognized as being odor sources. So we will finish showing some examples of silicon surfactants from the new PFJ range of additives, specifically surfactant for MDI, which is STBP1234 PFJ. A recommended surfactant when we produce MDI TDI formulations, STBP1254 PFJ. And two references for TDI formulations, STBP1258 PFJ and 1259 PFJ. And now, let us give you some key figures about Concentrol. Concentrol is an international chemical company based in the southwestern part of Europe. We have been manufacturing as chemical specialties since 1968. We have been in the field for almost 80 years. Performance Materials is the division that includes silicon surfactants and other products like release agents for the polyurethane foams, adhesives, and mold cleaners for different industries such as automotive industry, comfort systems, footwear, among others. Our headquarters account for a total surface of 55,000 square meters. 1,000 square meters of them belong to laboratories. Moreover, we have a subsidiary in Chicago, in the United States, and a regional center and R&D site in Wuxi, China. So thank you very much for attending this webinar. It will be a pleasure to discuss any pending topic and to answer any question that you can have.
Thank you very much, Josep. Now we can start with the Q&A session. If you have any questions that you have not already written, please write them down now in the enabled space. So let's start with the first question that we have. Do you perform the testing by yourself?
Thank you for the question. We do the analysis using gas chromatography on the surfactant side. So we are able to analyze the emissions on the surfactant side. But when we need to make the analysis on a foam, we used to work with external laboratories that are able to do this kind of analysis. So at this moment, we are not doing the analysis of foams directly by ourselves.
Okay. The next question that we have is, in your different family products, standard PF and PFG, you can improve the aldehyde and aromatic emissions. Are there any differences at the performance of the foam between these different families?
No. When we did the presentation of the PFJ references, we first rely on laboratory trials when we ensure that the performance of both families is the same. And also we had made external testing with partners and consumers that they had been able to do the trials, and there is no difference between the PF and the PFJ on the performance from the performance point of view.
Great, Josep. Here it goes, the next one. A low aldehyde and aromatic compounds guarantee that low VOCs?
A lower content on aldehyde and aromatics we can consider as an emissions. So yes, we can consider as part of the VOC. So reducing both, we will have also better lower emissions on VOC. But also we need to take into account that there are other chemicals, not only aldehydes and aromatics, which also they are contributors to the VOC. So we will reduce the emissions when we reduce the aromatic and aldehyde, but also we need to take into account that there are other substances that must be also investigated.
Thank you, Josep. Really detailed answer. Our attendees are asking if all our references are PFG.
The PFG range of additives was introduced 2 years ago. From step by step, we have adapted most of the references that we have in our existing catalog to the new PFG range. So at this moment, we can say that almost all the references, they have a PFG alternative. But it's true that some very old references that also they have a high VOC, and they are almost not used nowadays in the industry. They had not been adapted to the new PFG range of additives.
Okay, and in the same line, they're asking if all the references are free of CVHC.
We have a high quantity of references that are free of cyclic siloxanes for MDI, TDI, and also for TDI alone. There are still some old references that they contain higher amounts of 0.1% of each cyclic, and they are, in this case, it is stated in the safety data sheet, the information. But this is nowadays not a problem to have silicone surfactants for each specific formulation that are really, that they have lower quantities of cyclic siloxanes. So, yeah.
Okay, great. We have some more questions. Do you recommend or do you know which is the best method for a regular screening of emissions? For example, in the production of car seats.
By our experience, we have seen that the sampling bags is a kind of experiment or analysis that can be done at a very relatively low cost. It's a quick method for the analysis of aldehydes and also VOC. So probably we can say that an analysis that uses sampling bags can be perhaps the better option if we would like to analyze not only VOC, also including the aldehydes and aromatics. If we are just analyzing the VOC and it's not so important to the analysis of the aldehydes and aromatics, probably the BD8278 method it's the most convenient one.
Well done. We can continue. Now, you have presented some data where you show that an H surfactant has higher aldehyde emissions. How did you make the comparison? Really interesting question.
Sorry, I didn't. I'm sorry, can you repeat, please? I didn't catch it.
Yes, of course. Here it goes. You have presented some data where you show that an H surfactant has higher aldehyde emissions. How did you make the comparison between the normal surfactant and the aged ones?
In this case, when we did the analysis of aged materials, we used to have a sample which has been stored for a certain period of time, like more than 1 year, in a controlled temperature conditions, and in this case using oxygen, not put in a inert atmosphere, and then this material has been analyzed after 1 year, and we did a fresh preparation of the same material, and we did the analysis at the same time. So the differences on the results, they will be related to the degradation observed in the surfactant. So this is the way we have a comparison between an aged sample and a freshly prepared one.
Okay, great. Here we have a question about another sector. Do you forecast a requirement of aldehydes in rigid foam or slab stock foam?
Probably yes. We have seen in the automotive industry that probably we can consider it. It's the first place or one of the first places where the stringent requirements on the emissions were included. But we see nowadays that, for example, the cyclic siloxane is a topic that it's important for slab stock conventional foams and also for rigid. So yes, probably yes. In the coming years, step by step, the requirements of lower emissions, wherever the type, aldehyde, aromatics, or VOCs, will be also will be included in rigid and conventional slab stock applications. So probably yes.
Okay, here it goes. The next one. The overall bad smell is more related to VOC or aldehydes?
The bad smell, as we discussed a little bit in the presentation, is related to some chemicals. Most of the chemicals that are nowadays analyzed are the aldehydes, so probably there is a relationship between them, but also sometimes the smell cannot be exactly evaluated or found, which is the source of the odor. So that's the reason why nowadays still we rely on trained people who are able to make this analysis, and that's the reason why there is no specific analytical method that is able to quantitatively measure the odor. So aldehydes, they play a role on the odor, but probably there are other chemicals that sometimes are not analyzed easily that also can be other sources. So.
Yeah, this is really interesting. The attendees are asking if we have some silicone stabilizers for HR foam that could be used in slab stock.
Some of the surfactants for HR foams, for TDI type of HR foams, they can be used in a slab stock, but only in the applications of very high density and at higher dosages. Usually the stabilizers that are used for molded HR foams, they are weaker, we can say, from the point of view of the stability to the system, than the surfactants that are used for slab stock conventional foams. So only in some certain cases where the density of the slab stock is really high and we are preparing HR slab stock foams, some silicones can be used in both applications, molded and slab stock.
We have our last question, as we have almost done with the time. Are the results of aldehydes and VOC proportional to the dosage of silicone in the polyurethane system?
We have seen that in an experiment that only in the case of one of the aldehydes, propanaldehyde, we found a direct relationship between the increase in the dosage and the increase on the propanaldehyde value. In the aromatics, and at least using our PFJ range of additives, we have not seen any relationship, and nor also in other substances. So probably yes, there is a small relationship. Increasing the dosage of the surfactant, we will increase the emissions, but only of a certain substances, not all the substances that are regularly analyzed on foams.
Thank you very much, Josep. This was the last question. So thank you everybody for participating. If you have more doubts or questions, please do not hesitate to contact us at the email address marketing@concentrol.com. marketing@concentrol.com. Thank you so much for attending our webinar. We hope that you have enjoyed it, and we hope to see you again in our next webinar.